Part C says find all the values of x on the interval for which the graph of g has a point of inflection. So inflection happens when g double prime changes direction. Okay, so g double prime needs to change direction. So we're going to write an expression for g double prime. So starting with g prime, we have g prime equals 2 plus f of x. So g double prime, we differentiate 2 to 0, and we differentiate f to f prime of x. So g prime is the same as f prime of x, or in other words, where does f prime change direction? Or where does f change direction? So f prime is the slope of f. So where does the slope of f change directions? Okay, so it looks like it changes direction going here. It's going up here and then starts going down here. So at that point, that is the point at which f prime equals positive here, f prime equals negative here. Okay, so when I draw my chart out, my second derivative at 0 goes from positive, which is concave up, to negative, which is concave down. So at that point, although that point doesn't actually have a derivative, okay, because f prime is not defined at that point of 0, we know that across that point there's a change of direction of the slope graph, which means that we have a change of concavity across that. So when we have a change of direction on the slope graph, that indicates going from a second derivative of positive to negative or negative to positive. That represents a point of inflection. So inflection occurs at x equals 0. For part D of this problem, we're being asked to find the average value of f from negative 3 to positive 1.5. So when we take a look at this graph, I'm just going to see if I can highlight this from negative 3. So to positive 1.5 is going to be the quarter circle, the big quarter circle, and the first triangle. Okay, that's going to be 1.5 at this point here. So those two areas are going to be 9 pi over 4 plus 2.25. Okay, so I'm going to put this into my average value formula. So the average value of f is equal to, well, the interval width is going to be 1.5 minus negative 3, or plus 3, and the integral from negative 3 to positive 1.5 under the graph of f of t. Okay, so this works out to be 1 over 4.5. The area has the quarter circle, 9 pi over 4, plus 2.25. That's going to be 9 over 4. Okay. So simplifying this out, this works out to be, when I multiply this through, I'm going to end up with 2 pi over 4 plus 2 over 4, and that's going to simplify to pi over 2 plus 1/2. Okay, so the average value of this is going to be approximately 2.04. So if you take a look at this graph, the average value of this graph is going to be somewhere around here between that interval. Between there, the area above and below that black line should be approximately the same.